Andhra Pradesh Public Service Commission, Government Polytechnic Lecturer, 2020 Electronics and Communication Engineering Question Paper Solutions, Part 1. Question number 1. The transfer function of system where impulse response is e power minus 3t. So given the impulse response is e power minus 3t and they ask to calculate the transfer function. We know that the transfer function of a system is Laplace transform of impulse response, that is Laplace transform of h of t given impulse response is e power minus 3t, that is transfer function is 1 by s plus 3 because Laplace transform of e power minus at is 1 by s plus a. Here the value of a is 3. So the correct option is 1 by s plus 3, option 2. Second question. The system with unity gain margin and zero phase margin. What is the nature of the system? The system with unity gain margin and zero phase margin is oscillatory system. The nature of such system is oscillatory. So let us see some more points. A system is said to be stable if gain is less than 1, that is gain margin greater than 1, and phase is greater than minus 180, that is phase margin is positive. Similarly, for unstable system, gain greater than 1, gain margin is less than 1, phase is less than minus 180 degrees, phase margin is negative. Therefore, for stable system, gain margin and phase margin both are positive. For unstable system, gain margin is negative as well as phase margin is negative. For marginally stable systems, gain margin and phase margin both are 0. So gain margin is 0, phase margin is 0. For stable system, gain margin positive, phase margin is also positive. No, for stable system, system, the gain crossover frequency omega gc is less than phase crossover frequency omega gc less than omega pc. For unstable system, gain crossover frequency is more than phase crossover frequency. For marginally stable system, gain crossover frequency is same as phase crossover frequency. Here unity gain margin 0, phase margin. Therefore the system is oscillatory or marginally stable. A system with unity gain margin, that is 0 dB, and 0 phase margin is marginally stable. This means the system is on verge of instability and the system will oscillate with sustained oscillations without damping. Next question. The Laplace transform of unit step function is, so the Laplace transform of unit step function, Laplace transform of u of t is 1 by s. Similarly, the Laplace transform of r of t ramp signal, that is Laplace transform of unit ramp signal r of t is t. It is 1 by s square. The Laplace transform of parabolic signal unit parabolic function is 1 by 2 t square. Laplace transform of 1 by 2 t square is 1 by s cube. Therefore the correct option is Laplace transform of u of t is 1 by s. Next question. What does the given image represents? The given image represents Gibbs phenomenon. This represents Gibbs phenomenon when approximating a discontinuous function like square wave using finite number of terms in its Fourier series. When approximating a discontinuous function using finite number of terms in its Fourier series, near the discontinuity the jumps exist, that is oscillations and overshoot exist at the discontinuity. Here in the figure, the thick black curve represents a square wave, and the color curves are partial Fourier series approximations with increasing number of terms. Here the black color represents square wave and the color signal represents Fourier series terms with increasing n value. The correct option is 3, Gibbs phenomenon. So aliasing means. Next question, the transfer function of tachometer is. So tachometer is a device used to measure the angular speed or angular velocity in control systems. Its transfer function describes the relationship between input shaft speed and output voltage. So the block diagram has been mentioned here. Theta of S is the input, E naught of S is the output. The transfer function of this tachometer is SKT. So transfer function is ratio of output by input in frequency domain. So that is SKT. So that is tachometer constant. Tachometer is a speed transducer used as a feedback element in and is used as a feedback element in control systems. So correct option is 1. Transfer function of tachometer is Ks. The transfer function of lead compensator. So for lead compensator, it introduce positive phase and it is a faster system. Similarly, lag compensator introduce negative phase and slower system. Let us see some more differences between lead and lag compensator. Lead compensator provides positive phase boost, improving the stability and speed, whereas lag compensator provides negative phase shift and helps to improve the steady state error, but it tends to slow down the system. For lead compensator, improves the transient response. It reduces the rise time, increases the bandwidth, increases the margin of stability, signal to noise ratio decreases. Similarly, lag compensator increases rise time, reduces the bandwidth, reduces the stability margin. This lag compensator mainly improves the steady state error. So here the correct option is the transfer function of lead and lag compensator is integers have positive and negative phase angles respectively, which makes the system faster and slower respectively. The correct option is 3. Next question. By decomposition property of a linear system, we can separate two components of a linear system, namely. So generally in a linear system, the total response is decomposed into zero input response and zero state response. So zero input response means the response only due to initial conditions. Only due to initial conditions. So zero state response means the response due to only for input, keeping initial conditions 0. So 0 state response, it is due to external input assuming initial conditions are 0. 0 input response is, it is only due to the initial conditions where the input is 0. That is a total response. So total response consists of two terms, 0 input component and 0 state component. Correct option is 2. Next question. If the loop gain is much greater than unity, so loop gain is A beta. If A beta is far greater than 1, then the closed loop gain is A by 1 plus A beta. The condition is given, so A beta is far greater than 1. Therefore, 1 plus A beta can be approximately written as A beta. Now substitute the same in loop gain. Closed loop gain is closed loop gain becomes A by A beta. So A is a open loop gain, A is open loop gain, and beta is feedback network gain or feedback factor. So it will become 1 by beta. So if open loop gain is much greater than unity, then closed loop gain is approximately equal to inverse of feedback factor. Correct option is 3. Next question. Given G of S transfer open open loop transfer function and H of S feedback network transfer function, then the system is, so generally type of the system is obtained from open loop transfer function G of S H of S, and the number of poles occurring at the origin determines the type of system. So this is the statements related to type of system. Next, so we know that G of S is 5 by S and H of S is 1 by S as per the question given below. 5 by S, 1 by S. So that is 5 by S square. Type of the system is obtained from open loop transfer function G of S H of S, and the type is the number of poles occurring at the origin. So here the number of poles occurring at the origin are 2. Type of the system is also 2. Similarly, the order of a transfer function is obtained from closed loop transfer function G of S by 1 plus G of S H of S, and the order is the highest power of characteristic equation determines the order of the system, that is the highest power in the denominator, that is order. Next question. If 0 is added in the forward path of a second order system, so if 0 is added in a system and the system type is not changed, it is nothing but a PD controller, proportional derivative controller, where bandwidth of the system increases, rise time decreases. It is nothing but it acts like a high pass filter, that is lead compensator. Lead compensator improves the transient response. Improves transient response. Rise time decreases means faster system. Correct option is 3. Rise time will decrease. If 0 is added in the forward path, rise time decreases. Next question, question number 11. The number of tons of wire needed to provide a potentiometer with a resolution of 0.05 is. So we know that the percentage resolution is given as 1 by number of turns into 100. We need to calculate the number of tons. Given resolution is 0.05 percentage. 0.05 percentage number of tons, let it be 1 by capital N into 100 percentage. Therefore number of tons is equal to 100 by 0.05. Its value is 2000. So 2000 tons are required. 2000 coil tons are required to provide a resolution of 0.05 percentage. Correct option 2. Question number 12. The eigenvalues of matrix A 0, 1, minus 6, minus 5 are. To find the eigenvalues, we need to obtain the characteristic equation, which is given as A minus lambda I is equal to 0, where I is identity matrix, lambda is a parameter. So using this equation, A minus lambda I modulus equation, 0, 1, minus 6, minus 5, minus lambda 1, 0, 0, 1. So it is minus lambda 1 minus 6 minus 5 minus lambda is equal to 0. To solve this, AD minus BC determinant is 5 plus lambda into lambda plus 6 is 0. So that is lambda square plus 5 lambda plus 6 is equal to 0. Lambda plus 2 lambda plus 3 is equal to 0. Therefore lambda is minus 2 comma minus 3. Here the eigenvalues are either minus 2 or minus 3. The eigenvalues for the given matrix are either minus 2 or minus 3. Correct option is 2. Question number 13. The Nyquist plot given below represents which circuit? So it is a all pass filter. This all pass filter passes all the frequencies equally in magnitude, that is its magnitude is unity. Alters only the phase of the input signal but not the amplitude. The transfer function of all pass filter is s minus a by s plus a, where a is a positive real number. The Nyquist plot for all pass filter are: the magnitude is constant and it is unity. Only the phase changes with respect to frequency. The magnitude is constant and the value of this magnitude is unity. It is a all pass filter. So the Nyquist plot given the given figure represents all pass filter. Correct option is 4. Next question. The steady state error for open loop system is 0.1. Given the steady state error for open loop system is 0.1. The steady state error for previously mentioned system being closed loop, this open loop control system is again converted to closed loop control system with unity negative feedback and applied a pulse input of 1 second having a magnitude of 10. Now what is a steady state error? So generally given here the open loop control system has steady state error of 0.1 when unity feedback is introduced. So this open loop control system becomes closed loop control systems and the system ability to correct the error improves and the applied input is pulse input, magnitude is 10. So here the applied input is also bounded input, then the steady state error becomes 0, that is closed loop unity feedback control system with bounded input produces 0 steady state error, or it will have 0 steady state error. So correct option is 4. Next question. If the output of system at a steady state does not agree with the input, then the system is said to have. So if output and the input are different, then it's said to have steady state error, which determines the accuracy of the system. This steady state error refers to the difference between desired output and the actual output of a control system when it reached the steady state. This steady state error is a direct measure of how accurately the system follows the input. So correct option is 4. If the output of the system at steady state does not agree with the input, then the system is said to have steady state error, which determines the accuracy of the system. Next question. The unit impulse response of a system is h of t, given h of t is e power minus t for t greater than 0. So t greater than 0 is a positive signal. For this system, steady state error or steady state value of the output for unit step input is input R of t is u of t. We know that Laplace transform of h of t is h of s, that is Laplace transform of e power minus t 1 by s plus 1, Laplace transform of input R of s, that is Laplace transform of u of t. U of t is 1 by s, output is y of s, R of s into h of s, 1 by s, 1 by s plus 1. The steady state value is limit s tends to 0, s into y of s, limit s tends to 0, s into y of s. Y of s is 1 by s, 1 by s plus 1. So steady state value is y of infinity is 1. So correct option is 2. Next question. Consider a system with transfer function g of s is s plus 6 by k s square plus s plus 6. If the damping ratio of the system is 0.5, then the value of k. Given transfer function is s plus 6 divided by k s square plus s plus 6, and the given damping ratio is 0.5. For a standard second order system, the characteristic equation is s square plus 2 zeta omega ns plus omega n square is equal to 0. Compare the given characteristic equation with standard characteristic equation. We will get, take k as common, s square plus 1 by k s plus 6 by k is equal to 0. Here omega n square is 6 by k, 2 zeta omega n is 1 by k. So we know that zeta is 0.5, omega n is this 1 by k, 2 into 0.5, omega n is square root of 6 by k, square root of 6 by k. So solve for this. 6 by k is equal to 1 by k square. Therefore k is 1 by 6. The value of k is 1 by 6. Correct option is 3. Next question. The sum of 9 minus 2j plus minus 7 plus minus 4j. 9 minus 2j minus 7 minus 4j. So it is 2 minus 6j. It is in rectangular form, a plus ib form. So convert it into polar form. So that is magnitude is a square plus b square under root square root of 4 plus 36 root 40, and angle theta is tan inverse of b by a, tan inverse of minus 6 by 2, tan inverse of minus 3, that is 71.6 minus 71.6 degrees. Exponential form is, that is polar form is r e power I theta. The value of r is square root of root 40 e power I or minus j e power j theta minus 71.6 degrees. Root 40 value is 6.3 e power minus j 71.6 degrees. Correct option is 2. Next question. Let x1 of t and x2 of t be periodic. x1 of given x1 of t is periodic with period t1. x2 of 2 is periodic with period t2. Now, the sum of two periodic signals is also a periodic signal if and only if the ratio of their periods is a rational number. So that is t1 by t2 is a rational number, and the resulting signal is periodic with period equal to LCM of t1 and t2. Correct option is 3. Under what condition the sum of x of t is periodic? If t1 by t2 is a rational number, then x of 2 is, so the resultant signal is periodic, and the period of resultant signal is given as LCM of t1 and t2. Next question. If the roots of characteristic equation is minus 2 plus j minus 2 minus j, so given roots of a system, so these are S plane, plus 2 minus 2, here it is minus 2, real axis, and this is imaginary axis. Here this value is minus 2 plus 2j, and here root is minus 2 minus 2j. Here the roots are given, roots are complex and different, complex and distinct, with a negative real part, with negative real parts. So that is roots are lying in left hand side of the S plane. Therefore the system is stable. Complex and distinct roots of second order system occurs when zeta less than 1 for underdamped system. So this is a stable system. Next question. Fourier transform of signum of t. Fourier transform of signum of t is 2 by j omega. Similarly, the Fourier transform of unit step function u of t is 1 by j omega plus pi delta of omega. Next, Fourier transform of cos omega naught t is pi delta of omega minus omega naught plus delta of omega plus omega naught. Fourier transform of sin omega naught t is pi by j delta of omega minus omega naught minus omega plus omega naught. So here for signum of t, Fourier transform is 2 by j omega. Correct option is 2. Next question. Which modulation technique does not use past information for modulation? So here delta modulation uses a difference between current and previous sample, depends on past information. Similarly, adaptive delta modulation and adaptive differential pulse code modulation. All these three systems uses past sample information, whereas pulse code modulation directly samples and quantize the amplitude of the signal at each instant of time without using past information. Therefore, correct option is PCM. PCM modulation technique does not use past information for modulation, whereas delta modulation, adaptive delta modulation, and adaptive differential pulse code modulation uses the past information, that is past sample value, to modulate the present sample value. Next question. The number of bits per symbol in 16 QAM is. So the number of bits per symbol is given as log m base 2, that is log 16 base 2. 4 bits per symbol. 16 QAM. Each symbol has, in 16 QAM, each symbol has 4 bits of information. That is correct option 1. Next question. Which of the following has least immunity? Obviously, the answer is amplitude shift keying because ASK encodes data in the amplitude of the carrier, which means it is highly sensitive to amplitude variations. So generally, the noise in communication channels are additive white Gaussian noise, which is a basic noise, typically affects the modulation of amplitude of the signal more than its frequency and phase. As a result, even small amplitude distortions caused by the noise can lead to incorrect detection of the signal, increasing bit error rate. Whereas in case of this frequency shift keying and phase shift keying, these are more robust because noise has less impact on phase and frequency than amplitude. So correct option is ASK. ASK is has least noise immunity, or it is more prone to noise. Next question. Autocorrelation function provides. So autocorrelation is a measure of similarity between signal with delayed version of itself over a different time lags. Whereas cross correlation is a measure of similarity between two different signals as a function of time shift applied to one of the signals. Autocorrelation measures the similarity of sequence with itself. Cross correlation measures similarity between two different sequences at different time lag. So correct option is 3. Measure of similarity between two signals. That is cross correlation. Next question. Fourier series assist in finding the steady state response by transferring the analysis from time domain to frequency domain. This Fourier tree series and Fourier transform converts a signal from one domain to other domain, that is from time domain to frequency domain. Fourier series is from or Fourier transform time domain to frequency domain, whereas inverse Fourier transform it converts from frequency domain to time domain analysis. Correct option is 1. Next question. The discrete Fourier transform of the sequence. Given sequence is x of n. X of n is 1 0 minus 1 0. So here the period of sequence or length of sequence is 4. On the discrete Fourier transform, x of k is sigma n is equal to 0 to n minus 1, where capital N is 4. X of n e power minus j 2 pi nk by n. So x of 0 is sigma n is equal to 0 to 3 x of n, that is sum of all 1 plus 0 minus 1 plus 0. It is 0. Next is x of 1 into minus j power 1 plus 0 minus 1 into it is j power 0 minus 1 into minus j whole square. So its value is 1 plus 1, it is 2. Similarly, x of 2 is 1 into minus 1 power 0 plus 0 minus 1 whole square plus 0, that is 1 minus 1 is 0. X of 3 is 1 into j power 0 plus 0 minus 1 into j square, that is 1 plus 1, its value is 2. Now x of capital X of k is 0 2 0 2. This is a discrete Fourier transform of given sequence x of n 0 to 0 2. Correct option is 2. Next question. Inverse Fourier transform of delta of omega minus omega naught is. We know that Fourier transform of 1 is 2 pi delta of omega. Fourier transform of e power j omega naught is 2 pi delta of omega minus omega naught. Therefore, inverse Fourier transform of delta of omega minus omega naught is 1 by 2 pi into e power j omega naught t. So 1 by 2 pi e power j omega naught t. It is inverse Fourier transform. So 1 by 2 pi e power j omega naught t. Correct option is 4. Next question. The maximum efficiency of amplitude modulation for single tone modulation is, single frequency modulation is. So we know that the total power and amplitude modulation signal is carrier power plus upper sideband power plus power in lower sideband. That is carrier power plus total sideband power. Total sideband power is Pc into mu square by 2. Carrier power is Pc. Therefore, total power is Pc into 1 plus mu square by 2. We know that efficiency is ratio of sideband power to total power. Sideband power is Pc mu square by 2 and total power is Pc into 1 plus mu square by 2. So Pc get cancelled. Its value is mu square by 2 plus mu square. And the efficiency is maximum. Efficiency is maximum when modulation index mu value is 1. If mu is 100%, then efficiency is maximum. That is 1 square by 2 plus 1 square. It is 1 by 3. The value of maximum efficiency is 33.33 percentage. Therefore, the maximum efficiency of amplitude modulated signal, single tone amplitude modulation signal is 33 percentage. Next question. The Fourier series expansion of signum of t has dash. So we know that f of minus x is equal to f of x. Then it is even function. So this signum, take signum signal. Signum of minus x is minus signum of x, which is an odd function. Cos of minus x is cos x, which is an even function. If you take separately, this signum function is odd function, this cos signal is even function. Now signum of minus x, signum of cos of minus x, which is an even function. Cos of minus x is cos x, signum of cos x is even function. And it also satisfies the signum of, for cos signal, the period is 2 pi. For cos signal, the total period is 2 pi. Signum of cos t plus or minus capital T by 2, where capital T is period, it is same as minus signum of cos t. So this signum of cos t is even function, as well as it satisfies half wave symmetric property. Therefore, the Fourier series of even half wave symmetry signal consists of only cosine terms with odd harmonics. It consists only cosine terms with odd harmonics because this signal is even plus half wave symmetric. So let us see the properties here. For even signal with half wave symmetric, the Fourier series consists of odd cosine terms. Fourier series consists of only cosine terms with odd harmonics. If the signal is odd half wave symmetric, the Fourier series consists of odd sine components. If signal is even, DC component and cosine components are present for even signal. If signal is odd, only sine terms are present. If signal is half wave symmetric, for half wave symmetric, odd sine and cosine terms are present. Here the given signal is even plus half wave symmetric. Therefore, its Fourier series consists of odd cosine terms only. Odd cosine terms. Correct option is 2. Next question. A system is given as x of t is equal to e power at into u of t. Here u of t is mentioned. The signal x of t is 0 for t less than 0. Therefore, the system is causal, because if the output at any time t depends on present and past but not on future, it is a causal system, and the system is either stable system or unstable system. If a value is greater than 0, here it is an unstable system. If a is less than 0, it is stable system. Therefore, stability depends on e power at. Stability depends on value of a. If a greater than 0, unstable system. If a less than 0, stable system. The value of stability depends on the value of a. We cannot define we cannot tell whether the system is stable or unstable. Because of u of t, the output is 0 for t less than 0, therefore it is causal. Because of this u of t, system output is 0 for t less than 0, hence causal. So it might be causal unstable system for a greater than 0, causal stable system for a less than 0. And this question is deleted from the question paper. Next question. Let x of t be a signal with Nyquist rate omega naught. The Nyquist rate for y of t, that y of t is x of t cos omega naught t. So we know that given signal has Nyquist rate omega naught, Nyquist frequency omega naught, and the given y of t is x of t cos omega naught t. So let us assume this is a spectrum of x of t, some triangular shaped signal. X of t has spectrum of x of omega. Now the spectrum of y of t is y of f is y of f, which is given as x of t cos omega naught t, that is x of t into 1 by 2 e power j omega naught t plus e power minus j omega naught t, 1 by 2 capital X of omega minus omega naught plus capital X of omega plus omega naught. The spectrum is shifted by omega naught times. The spectrum is shifted to omega naught. So now the spectrum is initially 0. Now spectrum is shifted to plus omega naught and minus omega naught. Now the highest frequency component is here. Highest frequency component is omega naught plus omega naught by 2, that is 3 omega naught by 2. The Nyquist rate is 2 times of high frequency component or maximum frequency component. So that is 2 times of 3 omega naught by 2. So therefore Nyquist rate for the signal y of t is 3 omega naught. Nyquist rate for the signal is 3 omega naught. Correct option is 4. Next question. If f of t is equal to minus f of t minus capital T by 2, period by 2. So this is a condition for half wave symmetry. If f of t plus or minus capital T by 2 is f of minus f of t minus f of t, then it is half wave symmetric. Signal is half wave symmetric. Next question. If the discrete time sequence x of n for n greater than 0 is n of n, then z transform of x of z is, we know that z transform of delta of n is 1, z transform of u of n is 1 by 1 minus z inverse for mod z greater than 1, z transform of minus u of n minus n minus 1 is 1 by 1 minus z inverse, but the region of convergence is mod z less than 1. The delta of n minus m is z transform minus m, z transform of a power n u of n 1 by 1 minus a z inverse for mod z greater than a. Similarly for non-causal signal 1 by 1 minus a z inverse, region of convergence is mod z less than a. Here the given question is n of n. So this question is deleted from the sequence x of n is not properly mentioned. The given question is deleted from the question paper. But here these are the different Z transforms for different signals with region of convergence. Next question. 8-point DFT of the signal x of n is 6 cos square pi by n. So this is a given signal x of n 6 cos square pi by n. If n is 0, x of 0 is 6. Similar likewise, x of n is 63036303. For this signal, we need to calculate the discrete Fourier transform, that is x of k. We know that capital X of 0 is sum of all these. So that is capital X of 0 is sigma n is equal to 0 to 7 small x of n. So that is 6 plus 3, 0 plus 0 plus 3 plus 6 plus 3 plus 0 plus 3. Its value is 24. So capital X of 0 is 24. That is option 4 and option 1 is eliminated. Only option 2, option 3 might be correct. Now see the fourth term 0, 1, 2, 3, 4. Fourth term in x of k, in option 2 it is 0. Fourth term in option 3 it is 12. Let us calculate capital X of 4. So upon calculation x of 4 value is 0. Therefore option 3 is also eliminated. Correct option is second one. The 8-point DFT of the signal given signal x of n is 24, 0, 12, 0, 0, 0, 12, 0. Option 2. Next question. In a communication system, the signal power is 13 dBm and noise power is minus 1 dBm. Then signal to noise ratio is it is a ratio of signal power to noise power, that is signal to noise ratio in dB minus signal power in dB minus noise power in dB, or signal power in dBm noise power in dBm. So that is given signal power is 13 dBm minus noise power is minus 1 dBm, decibel per milli. Now its value is 14 dB but not dBm because milli get cancelled. So correct option is 1. Signal to noise ratio is 14 dB. Next question. The channel capacity of noise free channel having m symbols is given by. For noise free channel capacity is log m base 2. So channel capacity is log m base 2 bits per symbol. Similarly for binary symmetric channel BSC, binary symmetric channel capacity is C is equal to 1 plus P log P 1 minus P log base to 1 minus P bits per symbol. Question number 38. What is the total power carried by sidebands in amplitude modulation for a single tone with modulation index 0.4? Okay. Total power carried by sidebands in amplitude modulation. That is efficiency of AM mu square by mu square plus 2 with modulation index is 0.4. 0.4 whole square divided by 0.4 whole square plus 2, that is 0.16, 2.16, 0.074. Its value is 7.4 percentage. The total power carried by the sidebands is 7.4 times of total power. Correct option is 3. Next question. The modulation index of amplitude modulation signal is 0.7. Given modulation index is 0.7 and carrier power is 14 watt. Then what is the sideband power? So sideband power is power in upper sideband, power in lower sideband. So the total sideband power is PC into mu square by 2. Carrier power is 14 watt, 0.7 whole square by 2. Its value is 3.43 watt. 3.43 watt. Calculate the Total power. Total power is the question might be it is not total sideband power, it is a total power. The total sideband power is 3.43 watt. Now total power PT is equal to carrier power plus total sideband power, that is 14 plus 3.43, 17.43 watt. So 17.43 watt as per the given options. But if the question is total sideband power, then option should be 3.43 watt. So this question also deleted from the question paper. So take it as total power. Next question. A periodic signal f of t has a period of 2. So this is a given signal, and the given signal f of t can be represented as like this diagrammatically. So its period is 2. Differentiate the given signal. So d by dt of f of t will have impulses at point where f of t has jumps. So this f of t has discontinuity at t is equal to 1, t is equal to 2, t is equal to 3, at t is equal to 3 discontinuity exists 4, and t is equal to minus 1, likewise it has discontinuities. So at t is equal to 0, at t is equal to 0, the magnitude of jump is from minus 1, which is a previous end, and plus 2. The magnitude of jump is 3. Similarly, at t is equal to 1, the magnitude of jump is from plus 2 to minus 1. So the magnitude of jump is minus 3. So for this, the first step is we are writing the signal in diagrammatic form, representing the signal in image, sketching the signal, and second one is differentiating the given signal, and third step is next step is this d by dt of f of t. So after differentiation, d by dt of f of t, it is 3 into g of t minus 3 into g of t minus 1, where this g of t is sigma k is equal to minus infinity to infinity delta of 2 minus t minus 2k, and comparing this with given equation a1 g of t minus t1, a2 g of t minus t2. So compare it with the given equation, that is a1 g of t minus t1 plus a2 g of t minus t2. Here a1 is plus 3 and a2 is minus 3. The value of t1 is 0. Here t1 is 0 and t2 is 1. t2 is 1. Therefore, magnitude of discontinuity is, this is one magnitude plus 3, here magnitude is minus 3, and time instant is 0, here time instant is 1. So plus 3 minus 3 0 comma 1 is the correct answer, option 2. Next question. Impulse response of discrete time filter is expressed as, here given h of z is 1 minus z inverse by 1 plus 0.5 z inverse. So that is 1 minus z inverse. So this denominator is written as 1 plus 0.5 z inverse whole power minus 1. We know that 1 plus x whole power minus 1 is 1 minus x plus x square minus x cube and so on. Expand this expression, write 1 minus z inverse 1 minus of 0.5 z inverse plus 0.25 z power minus 2 minus 0.125 z power minus 3 and so on, and then do cross multiplication. After cross multiplication, we have h of z is 1 minus 1.5 z inverse plus 0.75 z power minus 2 minus minus 0.125 minus 0.25, that is 0.325. Its value is positive. 0.325 z power minus 3 plus and so on. Now the coefficients are h of 0 is 1, h of 1 is minus 1.5, h of 2 is 0.75, h of 3 is minus 0.325. Correct option is second one. So given h of z, write it as 1 plus 0.5 z inverse whole inverse. So using this binomial expansion, expand the signal and then multiply these two signals, we will get the coefficients. Next question. A PCM signal to quantization noise ratio for sinusoidal signal quantized using 10-bit PCM is a signal to quantization noise ratio for pulse code modulation which sinusoidal input is given as 6n plus 1.76 dB. So given the value of n is 10 bit. So that is number of bits used to encode each sample in PCM is 10. Now signal to quantization noise ratio is 6n, 6 into 10 plus 1.76, that is 61.76 dB. So approximately written as 62 dB. The nearest option is 62 dB. Next question. If the unit step response of a network is 1 minus e power minus at, then impulse response. So impulse response is differentiation of unit step response d by dt of step response 1 minus e power minus at. So d by dt of constant is 0 minus d by dt of e power minus at. So that is minus of minus a e power minus at. That is a into e power minus at. So correct option is 2. So we know that d by dx of e power minus ax is minus a into e power minus ax. Next question. For the value of omega naught, discrete time signal x of n is e power j omega naught n is given. Find the period of the signal. So we know that x of n is e power j omega naught and the period of the signal is x of small n plus capital N is equal to same as x of n. So the condition for periodicity, x of small n plus capital N is x of n for all values of n. So that is e power j omega naught n into e power j omega naught capital N. So this is equation 1, equation 2. So signal is said to be periodic if x of n is same as x of small n plus capital N. That is e power j omega naught n is equal to e power j omega naught n into e power j omega naught capital N. Now e power j omega naught capital N value is 1 because this is get cancelled. So capital 1 is, it can be written as e power j 0 or j 2 pi or n pi. N is a even number. It can be written as e power j 2 pi some k value. K is an any integer. Now omega naught n is e 2 pi k. The value of omega naught is 2 pi by sorry, the value of periodicity or omega naught is 2 pi by n into k, where k is any integer. So omega naught is 2 pi m by n, where m is a positive integer. Next question. The relationship between electric field, current density and conductivity is J is equal to sigma E. So correct option is 1. Next question. The dominant mode of any waveguide is, in a waveguide, dominant mode is a mode with highest cutoff frequency or lowest cutoff frequency, or dominant mode is a mode with least attenuation. Because waveguides acts as a high pass filter, the dominant mode is the one with lowest cutoff frequency. Correct option is 2. Next question. The capacitance per unit length and characteristic impedance of lossless transmission line is C and Z respectively. What is the velocity of wave traveling in the transmission line? So we know that transmission line has a characteristic impedance Z0 is equal to R plus j omega L by G plus j omega C. Given the line is lossless transmission line, therefore R is 0, Z is 0, characteristic impedance Z0 is equal to L by C. Z0 square is equal to L by C. Phase velocity is 1 by square root of LC, or phase velocity can be written as omega by beta. So omega is omega by beta value is omega root LC, that is phase velocity is 1 by root LC. Velocity is 1 by root LC. So in 1 by root LC, take Z0 square root of root L by C, multiply and divided with C by C. Root LC by C square. So root LC can be written as, or arrange the expression, Z0 into C is equal to root LC. So root LC is 1 by phase velocity. Now phase velocity Vp is 1 by Z0 into C. So phase velocity Vp is equal to 1 by root LC, or 1 by characteristic impedance Z0 into C. So correct option is 2. Next question. Light is good for telecommunications because it is a high frequency carrier. It is in optical range where it is in 10 hertz, 10 terahertz range. The bandwidth is very high. Next question. J is equal to sigma E. Sigma is equal to J by E. Next question. The path of ray is going from high index material to low index material. So refractive index is different in different media, and the Snell's law for the following is, so the Snell's law describes how light bends refract when it passes from one medium to another medium. So that is n1 sin theta 1, n2 sin theta 2, where n1 and n2 are refractive index, theta 1 is the angle of incidence, theta 2 is the angle of refraction. Therefore n1 sin alpha is equal to n2 sin beta. This is the Snell's law for a light traveling in different media. Correct option is 1. This part 1 ends.